I am going to do is talk about the homework from yesterday first, and I do need to upload it. Give me 1 second. So here's the link if you do want to follow along. Uh, Actually, no, this is somebody else's solution. This is Eric Jenny's solution. That's okay. Well, I do actually like his solution a lot. So why don't I use this for now? All right. So, hi, Eric. So we're going over the homework, and if this looks familiar, it's because I have accidentally uploaded your solution. But here it is. It's actually really, really clean. We have a Boolean array of length 4001 by 4001. So, like I said in class, we do have to. Um, this is one way to represent the grid. And if we use the even numbers to represent the actual coordinates of where you be landing at each point, and we use the odd coordinates um, to denote whether there's a fence there. Right, so the map is going to be at most in the regular xy coordinate, it's going to be at most from negative 1,000 to positive 1,000. So that translates to if you scale that by 2, right, then that translates to 2,000 to negative 2,000 to positive 2,000. And since we need to shift it so that we don't use negative indices in the array, so it goes from 0 to 4,001. Okay. Um, Right, so we loop n times to simulate those n instructions going north, south, east, west, and we check for whether there's a fence directly at the position that we're going into the point at, and whether the point has already been visited or not. So this Boolean array, if we're looking at a point, it's looking at whether a point has been visited or not. If it's looking at a fence, it's whether there is a fence there or not. And yeah, that's it. So I do really like this solution. It's surprisingly clean. And I do want to post my solution as well. So if I refresh this, this is the way I did it. It's a little bit different, but works the same way. It's a bit more complex because I have to use the point class. I have to figure out the hash code and the equals thing, but the concept is similar. Questions on this homework? Okay, so what I want to do today is talk about flood fill. Okay, and it's an algorithm that does show up quite a bit in the silver division. Basically, if you look at my screen share, the flood fill algorithm is used for something like this. Let's say we have a circle here. We're drawing on a 2D grid, and let's say there's a circle. And if you ever use paint, there is this tool here. That's the paint bucket tool, and it does this flood fill thing where wherever you click, it starts filling a color at that position, and it's gonna flood to the entirety of the area until it hits um, colors of different pixels. Uh, or I should say pixels of different colors. So I'm gonna click on a white section here, right? So wherever I click, it's gonna flood that particular pixel and surrounding white pixels that are of the same color. to the color I selected. So that's flood fill. Sorry, I need to delete this. So how do we do flood fill? Well, the idea is we have a map of some sort, like a 2D grid essentially, uh, and it basically has within the map, within the 2D grid, either like what color it is shaded with, or some sort of property, and we start somewhere in the 2D grid, and we mark places that we flooded or not, um, and sort of recursively do that algorithm. If that sounds a bit confusing, here, how about this? Why don't we actually do a problem together that uses that? So I think it'll be more clear if we actually A, look at the problem, and B, talk about the algorithm in the context of that problem. So yeah, here's the link to the problem that we're looking at. It's called cow art. All right, does anyone need more time? So this problem here, we're essentially counting the number of regions. It's throwing a wrench in there to say like there's different ways of counting, like humans and cows count the regions a little bit differently. Cows, I believe they say are red-green colorblind. Um, yep, but we just need to apply the same algorithm, uh, the same flood fill algorithm for both cows and humans, right? Um,
Sorry. So is it that if you have like red and green next to each other, they can't tell the difference? They can't see it as
correct.
one?
Yeah,
Okay.
correct. That is correct. That is exactly what it's saying here.
And
Uh,
not if it's red and green separately. Okay.
yep. Yeah. Um, all right. So let me copy the sample input here. Okay. So right. So if we were human, right, it would supposedly look like three distinct or four distinct regions, right? So right. So that's one, and then uh, that's another, and then the rest are blues, right? Yeah. So that's four different regions. However, the cows is gonna see this group of R's and this group of G's as the same. Okay. Um, so in this problem, the goal is to count uh, different counts a different number of regions, contiguous regions of same color. Let's do the human one first, because that is a bit easier to deal with. Like we don't have to deal with that really weird red-green color blind thing. Um, right. So how do we do this? um, let's first define what we need to do, what data structure we need to run that flood fill algorithm. Uh, we do want to make sure that a spot, when it's been visited, when it's been looked at once, and we assign it to a region, it doesn't get assigned to any other region again. Okay, so we need a way to mark a position in the grid as visited and assigned as a region, right? So that it will not be counted towards other regions. Okay, so what we can do here is use, um, there's different ways of doing it. Here's one way I like to use. I can literally use a 2D array Boolean. So let's say the map. So um, I can represent the map using a 2D char array of uh, uh, m by m. Okay, or is it? Oh, in this case, it's n by n. All right. Yeah, and then I can also have a corresponding visited array to say visited of ij denotes whether we have visited and marked position ij. Okay, yeah. And what else do we need? One thing that is tricky about this problem is like when we look at a cell, right? So let's say we start a flood fill, right? Let's say I want to look at what cells are connected, what positions are connected to this region, starting at the position 00. What I need to do is look at what color that is, right? And I need to look at the neighboring cells and see like whether they have the same color. And if they do, I need to flood from there, right? And then with that cell, right, I need to recursively do this process. So this problem, this algorithm, you can do recursively. Although I'm going to show you two different ways of doing it. One is recursive, one's not. Either way is going to work. I actually prefer the non-recursive one, but it's really up to your personal preference. Okay. All right. So let's go ahead and actually implement this. So I'm going to go to my workspace and make a new file for this. All right, so here's my starting code. Let's parse the input. So here I'm going to be using a jagged array, and it's not actually jagged, it's n by n. All rows have the same length, but I'm doing it this way because I'm parsing the entire line as one string. All right, so there's that. And then what I need next is, like I said, right, a way to mark whether a cell has already been visited or not. Right, so I will go and do that. And as a reminder, when you create a Boolean array like this, by default, all the entries are false. Okay, good. So now here's what I basically need to do. I need to loop through each cell. And actually, so I'm going to use R and C for row and column here. Right, loop through each cell. And I want to say, if we haven't looked at that region, if we haven't visited that particular cell, if we have not visited position RC, start flooding at that position. All right, so if not visited RC, right, then I can go ahead and run the flood fill algorithm. Now we don't have a function for that yet, but I'm going to pretend that I do. I'm going to say flood. So I'm going to start the flood at that position, right? So the flood function needs to take in, of course, the map, right? It also needs to take in the starting position where we're doing the flooding. What else does it need? It also needs the visited array because the flood function will mark off any cells, any position connected to position RC with same color as visited, so that we don't have to visit it again. Okay, so we need to count the number of regions. So essentially what we need is just have a count, right, to count how many times we need to do this flooding thing. And then here we can say count plus plus. Okay, questions on this part so far? Yeah, so this is just how we set this up to count the number of regions. We haven't talked about the actual flood, well, we haven't actually implemented the flood field algorithm, which is going to actually mark all connected cells with the same color as visited. So let's go ahead and implement that. So like how I used it in the input, the first in the main, the first input is the map, and then the row and column indices, and then the Boolean array of visited. Okay. Okay. So there's different ways of doing it, but one thing you want to look at is make sure that it's consistent with how we're using it in the main as well. So it says if I haven't visited cell RC, then go ahead and do the flooding. So that would be like probably the first thing you want to do with the flood is check to see. Uh, uh, the first thing you probably want to do here is mark off that we're now visiting that position. Okay, so we'll set this to true. I do want to modify this a little bit. I actually want to surround this with an if a bit later, but I'm going to stick with this for now. Okay. And then I need to look at neighboring cells and see if they have same color. If so, flood there as well. Right, so the neighboring cells, which means that the cells to the north, south, east, west, right? So we can list out the four cases, or I'm going to use that trick that we kind of did yesterday where uh, I mark out the different ways. Right, so this is what happens if you go south and then east and then north and then west. Uh, I didn't bother defining the indices because it doesn't really matter as much. But basically, I want to loop through the four neighboring cells, and the 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 row and column indices of the neighbor uh, is going to be r plus dr of I and c plus dc of I, right? Okay. Uh, I want to see whether this cell have same color as um, as the position R and C, right? So I want to check if map of new R, new C is equal to map of R and C, right? So if so, then I want to flood that guy as well, right? So I can do this recursively. I'd say flood, passing the map, passing the new R and C, and the same visited array. All right. So that's the concept. I'm actually missing something really crucial here. Um, but any questions on this so far? So just to emphasize this, this is where the recursion is happening. The idea is where we look at the cell that we're currently on, we mark as visited, and then look at the neighboring cells and see like whether we should be flooding at those cells as well, right? And we should be if they have the same color as the one that I'm currently on, um, right? And with the recursive process, we can flood fill the entire region um, that that share the same color as my starting point. Um, so what am I missing here? One thing I'd be really careful is it's easy to go out of bounds with the new C, new R and new C thing, right? I am finding out the indices of positions to the north, south, east, west of my current cell. And especially if I'm starting at the top left corner, right? Then like two out of the four neighboring cells, they don't actually exist, right? They're out of the map. And if we leave this as such, we get an array index out of bounds exception. Um, Fortunately, it's not too hard to guard against that. What you can do is just make sure that the indices don't go out of bounds. It's annoying. You do need to make four checks, but um, it's not too bad. And then these guys, let me indent. Okay.
The end of the new C function isn't complete though.
The new end of the news.
Like
Oh,
in
yeah, yeah. Yeah, 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 yeah. You're right. Thank you. Yeah, so that's flood fill. Yep. So let's see. If we go back to the problem, right? Actually, remember how it says like we need to count the number of regions as seen by humans and number of regions as seen by cows. So we need to actually like do this same process again, but with the uh, what you may call it, uh, but with the red and green cells be treated as one region. So what's like the best way of doing that? Uh, how about this? How about since I need to do this twice, I can do this here, but let's actually like parameterize this logic out that's in the main right now into its own function. Um, Otherwise, it could get pretty ugly. So this part here, I'm just gonna put this in a function. Let me call this count regions. All right, and this is going to take in one thing, and that is the map. Do you also need to get the end-to-end thing here? Okay. All right. So we need to do it once for humans, and we need to do it once for cows. And you might be thinking, okay, so do we need to write like a completely separate flood fill where like I go here, right? So this, in particular, this logic here, right, is checking whether the neighboring cell has the exact same color as uh, the current cell, right? So do I have to write the same thing and like just change this and just basically change this logic, but have everything uh, else stays the same? You can do it that way. There's actually a neat trick we can do here where um, we count it once for humans, and then we can modify the map so that all reds turn to greens. And with that, it actually makes our life a lot easier, right? Because we can just go ahead and use the exact same algorithm, right? So we can actually go in and modify the map. So I can say if this is equal to R, change it to G. Okay. And then we do the same thing once, count regions on the map again, and this time it'll be for cows, right? And then we print out the count for humans and print out the count for cows, and we're done. Let's see. Oh, I missed a little thing here. And the return, I forgot to return in the counts region. So go and return counts. But yeah,
Why do
that
you want?
is, sorry?
Oh, why do you want to modify the map so that all our reds are turned to green?
Because that way, then I can just use the exact same algorithm to count uh, for like how many regions there are as viewed by a cow.
But if like say you have a red and a red next to each other, and
Mhm.
if you're searching for two reds next to each other, you might count the wrong one.
Uh, so let's say this is the map. Let's say the map goes like red, 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 green, 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 red, red, red. So as viewed by a human, how many regions are there?
Um, 9,
No,
1.
there is one
Oh, that. Okay, three.
unit for the R's, and one for the G's, and one for the R's. So that's three. As viewed
Yeah,
by a cow, how many regions are there here?
one.
One, right? Because the cow, for all intents and purpose, is seeing this.
Yeah.
Does that make sense?
Oh. Oh, okay. So you're just trying to make it like that. Okay, yeah.
Yeah, 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 yeah. Yeah, it does seem a bit unholy to change the representation of the map. Uh, it does feel a little bit dirty doing it, but it works. Okay, so let's look at another flood fill problem. I'm gonna pull that up from my notes. Give me 1 second. This one's gonna be fun. This one's hard. It's called counts cross. All right, so I am going to delete the code in the pad and paste this next problem here. Okay, so let's go and read this. All right, are we good? Okay, so again, with a problem like this one where we have a map, it helps to draw a 2D grid on paper, or in this case, I'm going to use paint. And so we have like a 3 by 3 grid, right? And it says, okay, so there's like 3 roads here. The first road connects the cell 2, 2 to 2, 3. So here it's using one indexing here, a bit annoying, but that's okay. So there's a road here like this, connecting row 2, column 2 to row 2, column 3, right? And there's one connecting 3, 3 and 3, 2. So 3, 3 and 3, 2 like this, right? And then finally, there's one last row one last road that connects 3, 3 with 2, 3. So 3, 3 to 2, 3. That looks like this, right? Let me also mark the position of the cows. So there's a cow at position 3, 3. There's a cow at position 2, 2. And there's a cow at position 2, 3. Right, so 3 different spots here. Right. Um, so the question is asking how many pairs of these cows can visit each other by basically going from cell to cell, but without actually ever crossing a road. Uh, it says here the answer is 2. Okay, so let's see. So we have um,
Is it coordinate based on like X, Y, or like an array?
so I'm assuming these are row and column indices.
Okay.
Okay. And let's see. So there's 1, 2, 3 pairs. And wait, actually, does that make sense? Count the number of distinct pairs of cows. Sorry. It's counting the number of cows where it is necessary to cross at least one road. Okay, that makes more sense. Okay, and the answer is 2. So with, for example, uh, this cow to this cow, right? We have to cross a road. I mean, we can try to go around, right? But then, like in the end, we still have to end up crossing a road. So these 2 pairs, they do need to cross a road. Same thing with this cow and this cow, right? So there's just no way around it. With these 2 pairs of cows, though, we can go around, right? So if I go like this, I'm going to cross a road, but if I actually go around, then um, I don't have to cross. Okay. So we do have 3 possible pairs, and 2 of these do, right? But 3 choose 2, right? So there's 3 cows. We choose 2 to pair up. So there's possible 3 pairings, and 2 of them do require us to cross a road. So Samuel, uh, I don't know. I don't have a good solution for you. Okay, so how do we do this? Well, this is flood fill, right? So what we can do is we can go to any one of the cows, right? So we loop through each of the cows that we have, and we go ahead and do a flood fill. So with flood fill, right, we go like north, south, east, west, and we have to check whether like there's a road blocking us or not. And we can use the same trick as we did um, with the homework yesterday, uh, where we expand the coordinates so that um, it takes up twice the size than it normally would. And we'll have the even indices as valid positions and odd indices as valid as like a wall, right, or road between the cells. So our solution is going to be something like this. It's for each cow C, right? We do a flood fill from position of cow C to count how many cows we can reach. Okay, so uh, let this count be equal to x. Okay, and then our answer is going to be, so this is the number of cows that we can actually reach without crossing a road. We're interested in finding how many cows we can reach uh, that requires us to cross a road when we in order to reach it, right? So the answer is going to be plus equals that. All right, so Victoria's asking, what about roads that point in different directions? Does the direction of the road matter in this solution? Yeah, it does. So what we can do is have a so in this case, this is like a 3x3 grid. We can expand it to a 6x6 grid. Or I should say 5x5 grid. So here are, so the points that I'm marking as X are the valid uh, coordinates of where the cows are, or where the cows may be, I should say. And when there's a road between them, we use the odd indices to denote that. So there's a road from cell 22 to 23, right? So we put a road there like this, okay? And then same thing with this guy, and same thing with this guy. Okay. Yeah. Questions on the approach to this?
So does flood fill start at the very top left corner and go all the way down to the bottom, to the very
It
bottom right
can,
corner?
but it does. It absolutely does not have to. What you can do is you can start to flood fill at a cow, right? Because what you want to do is you want to simulate being that cow and see how many other cows you can reach from my current
Right.
position without crossing any roads. So you will be starting the flood fill at where that cow would be.
I see. And then you just see where the other cars are and how many roads you have to incur.
Correct. All right, so I don't have anything else prepped for this class. So you guys can start working on this solution. So the flood fill algorithm is a bit tricky to implement. So you can go ahead and I'm going to spend more time. I'm going to have you guys spend more time in class, starting your homework. So I'm going to assign this for homework. So Samuel, since you've already done this before, while you're waiting, can you? Well, you I know you're in gold, but you signed up for this silver class anyway. Uh, can you maybe list out some topics that you would like me to go over that's in silver, so I can plan for the next 3 days?
Um, have we done like hashing?
Uh, that's the class you missed either yesterday or 2 days ago.
Okay. Hashing is pretty simple, so I already know it. I don't think we need a
Okay.
breakdown on that, but I can't think of any silver topics right now. Probably more gold topics at the moment.
All right.
If I think of
Well,
one, I'll definitely email you.
okay, yeah, because I do feel a bit bad for you, but on the other hand, I can't go to gold topics.
Yeah,
All
that's all right. That's all right.
right. If you want to challenge Samuel, there's one flood fill problem. I don't know if you did the U.S. Open in the silver level, the very last, the very latest one. It does have a pretty challenging flood fill problem. Forgot what it's called. It's called Where's Bessie? Have you done that one? Here, let me give you the link. So guys, right? So go on your virtual machine and start coding. All right. Um, oh, Victoria, yes, of course, I can give you the boilerplate code. On the other hand, I do highly recommend that you set up your Eclipse so that it auto generates that boilerplate. But yes, I can give that to you. So it is called count cross. All right, and here it is. And Samuel, if you want a challenge, you can try this one. Um, this is the Where Bessie problem from US Open.
Yeah, I'm reading it right now.
Okay. Eric, that's fine. I won't be able to look at your code. Just if you have questions, I guess flag say something. Dude, Sid, stop naming things so long.
I want to make sure I'm organized.
All right, well. It's fine here, but in the real contest, I would consider not doing that.
Yeah, for time.
Yeah. Oh, Victoria, yeah, you already have Eclipse open. Let's see. So yeah, I think you just have to minimize. Yeah, there you go. And I can get rid of that as well. All right.
Do you suggest storing the number of roads and the position of the cows in arrays, or maybe another data type?
Uh, in like a 2D array, an n by 2 array, maybe. Yeah, that would be sufficient. Yeah, because you need to loop through each of the starting position of the cows. Yeah.
Okay. And for the road, like for the format of describing the roads, it's just like 2 2 2 3. That's like it's the road is going from 2 to 2.
Cell 2, cell row 2, column 2 to row 2, column 3, and it's using one indexing, so you
Oh, okay.
just be careful with that. Okay.
Okay.
Sorry, I'll be right back. All right, I'm back. Anyone got questions? You guys are a bit quiet. Siddharth, be careful with the dimension of that array. It's fine to do it that way.
Sorry.
Yes, good.
Yeah.
Hmm.
Okay.
Right, Siddharth. Yeah, think about how you want to represent the map. Yeah, that's gonna be the harder part for that problem.
I'm guessing a 2D array is way too inefficient.
I think that's fine. What's wrong with 2D array? It's gonna be, what is it? It's not that bad.
Yeah. Let's see.
Yeah, so the actual grid is 100 by 100. So if you do 200 by
Oh,
200, that's only 40,000. That's fine. Yeah.
yeah. That's good. and each cell is one say integer in the array.
I'm sorry, say that again.
Is each cell like one integer in the array?
It is each cell one integer in the array. I I mean yes. Like
Or is it because like
yeah,
what
yeah.
the representation? Okay, yeah,
Well, how are you representing the cells?
by an array. Oh, I'm sorry, by by a tree array.
Uh, Dimension.
100 by 100.
Uh, well, how would you represent the roads then?
Um, or should I do 200 by 200 and like
Yeah,
one of
yeah. So
the
that's what I recommend. You can do that differently. There are different ways of representing it, but that's one way. Yep.
okay, and with flood fill, it's basically it takes every square around it and then searches that, and then the square around the same thing for the next layer of squares and does that.
Correct.
Okay.
Yep. All right. So we are out of time. So yeah, finish that for homework, and I will see you guys next week. So three more classes next week: Monday, Tuesday, Wednesday. Um, at this point, we do have covered mostly like all of the all of the main silver topics. So the last 3 days, we'll be looking at harder problems that will combine uh, possibly two or more topics that we've learned within the problem, and um, also review maybe problems that are not necessarily cross-topic, but just very difficult. Uh, but yeah, so that's gonna be for next week, and I will see you guys then. Take care.
Right. Right.